محمود باشا.
اهلا اهلا اهلا، ازيك يا احمد؟
اهلا. ازيك يا بيه؟ اخبارك انت عامل ايه؟
كله تمام الحمد لله. هذه
الحمد
المكالمة
لله.
ربما تكون مسجلة.
لا، هي واضح
اوكي،
انها مسجله،
هي
مش ربما، هي اكيد مسجله.
بس بحذرك يعني عشان لو عايز تقول حاجة كده ولا
لا
كده
لا لا.
تبقى عارف. تبقى عارف مش ان في حد خدعنا. لا لا، كله زي الفل الحمد لله.
الحمد لله رب العالمين.
طيب كويس كويس. ازيك عامل ايه؟
كله تمام. انت ايه الاخبار؟
انا بالنسبة للموضوع اللي كنت بعتلي فيه مسج ده،
لا لا، خلاص عادي يعني،
اه
ما تقولش بالك ليه.
طلع مظبوط، طلع في حاجة
اه،
كده. بس انا مش عارف هي تبع ايه بصراحة، ما اكذبش عليك.
مش لازم
والموبايل اللي عندي
احنا.
ما بيقوليش يعني، ما بيقوليش هي تبع ايه.
هي ما
مش
بيقولش،
حاجة.
وما فيش حد فاهم حاجة، واحنا بقى كمان حتى ما نزلناش اصلا حاجة، فالدنيا يعني اخر لخبطة بصراحة.
alright. احنا بس ممكن يعني احنا جورج دخل اهو كويس، وفي عمر كويس تمام. جورج صوته بيقطع شوية، بس يعني ان شاء الله تكتير هاي المشكلة قريبا. انا already sharing.
انت
انا
بقول لك،
ماشي.
انت عندك الريكوردنج بتاع اول سيشن، ما عرفتش احضرها عشان الظروف اللي كانت عندي في مصر دي. عندك الريكوردنج بتاعها؟ تبعتها لي.
والله بس ايوه يا باشا، بس انا حطيت الفيديو اونلاين. هو يعني فيديو تعبان يعني، مش سيشن جامد قوي يعني. بس
مش مشكلة، عادي يعني.
مش مشكله، كلنا غلابه. المهم جيت اعمل له ابلود، قال لي انت الحجم بتاعه كبير بعد ما طلع عيني يعني.
اوكي.
فغالبا هنعمل
طب
له
ينفع
ابلود
ترفعه على
تاني يعني.
وان درايف؟
لا لا، ما انا كنت يعني جيت ارفعه على وان درايف. عندنا احنا انترنال، ف فانترنال ما حدش هيشوفه من اللي بره يعني، من
اه،
بره
اوكي.
الشركه. فحبيت احطه يعني، المهم يعني. ففي الاخر حطيته على اليوتيوب. بعد كده فوجئت ان هو بعد ما خلص كل حاجه، الكلام ده من شويه يعني، لقيته بيقول لي اكسيد
اه،
الماكسيمم
اوكي.
لينث ولازم تفيريفاي الاكونت بتاعك. عملت فيريفاينج، بس قال لي احنا فتحنا فيديو غلط.
احنا كنا بنرخم عليه.
دلني يعني. بعد ما عمل ابلود ل 1 جيجا وشويه، قال لك خلاص احنا زعلانين منك يعني. فانا سايب الايمج او الحاجات دي ايفيدنس يعني.
اه، اوكي.
اوكي تمام تمام. طيب احنا كنا المرة اللي فاتت docs.docker.com اعتقد getting started، ده اللي احنا وصلنا له. طيب احنا we can describe what we have now. Okay, what I have now, there is a website, or there is actually many websites. They are called the Docker Playground. They are actually not only for Docker, they are for Docker and Kubernetes. So this is just you log in with your with an account, with Docker account or GitHub account. Then you can create environments to play with. Okay. We did not yet start. Okay, we haven't started yet. Okay.
سامعيني شباب؟
سامعينك يا باشا. We hear you.
perfect.
سامعينك جورج،
اوكي.
انت داخل بثلاث شخصيات ليه يا جورج؟
لا لا
لانه
جورج
من الموبايل اب وكول باك على ماي لاين ومن اللابتوب.
اوكي.
ما شاء
بس
الله
كل
شباب
شوية
عدوا خلاص.
جورج واحد،
شباب
جورج
جامدين جدا.
اثنين، جورج ثلاثة.
زي زمان عارف.
اه بالظبط.
جورج الخامس عشر.
هلو كيف؟
هلو. هاي عمر.
هلا
how are you?
يا عمر، الحمد لله. and you?
Good,
Hi
good.
Omar, how are
Everything
you?
fine.
Hi Ahmed. Fine, thank you. And you?
سامح، سامعني برضو؟ Can you hear me
سامعينك
guys?
سامع. Yes.
Yes,
Very
we
good.
hear you well.
هلا سامع،
طيب
اخبارك؟
تمام
كويس.
تمام. Thank you.
يلا.
حد بقى يشرح لنا احنا عملنا ايه المرة اللي فاتت؟
المرة اللي فاتت اتكلمنا على بدأنا نتكلم على دوكرز وان نعمل اكونت على دوكر the idea of docker، بس ما اتكلمناش في كوبرنيتس لسه يعني.
اوكي استعجل انت. اوكي. alright. طيب احنا مظبوط، يعني الكلام كان مظبوط. الفكرة اللي كنا اتكلمنا فيها our discussion last time was about the three main topics that are they are hot topics today in Micro Focus, which are Docker, Kubernetes, and CDF. Okay, then I have described that we have many thoughts we can share. Okay, it's open also for everybody to share whatever he thinks is perfect for these sessions. Okay, the idea, my main intention is to describe the whole Docker and Kubernetes story from the operations point of view. Okay, because I feel that the description of Docker and Kubernetes in most of the cases are from the development point of view. Okay, or mix DevOps, but mainly it needs somehow knowledge about development. Okay, while I have different perspective for that, so I want to share that perspective for everyone. And we have lately many discussions with our partners and customers, and we already had like one-to-one sessions or meetings or discussions. So I decided to have this call to share these thoughts with a group of people, so we can be more efficient in sharing the message. I invited George Farah also. He's already one of the good guys in this area, and we had together made similar presentations. So he can also give us his inputs, and also all of you, you are already experienced in the field, and you can share with us your thoughts. And also for myself, I really face. Sometimes I feel that I had the feeling that I have a good knowledge and good command of these things, and in the middle of nowhere, I got into a situation where I have to spend many time, spend a really huge amount of time to troubleshoot and solve the issue. And I got into more knowledge, and I had like more experience, but this experience is not shared with everybody or with anybody. So these kind of sessions are like a door opener for me and for you to share any experience we have. I will be in control just to organize the sessions. Just in case if somebody wants to share anything during the session, he is so much welcome. If you want to prepare for something and you want to share it in the next sessions, you should just contact me to align for the timing. I don't have a strict agenda, so it's all about us and about how we share these topics. Yeah. So last time I have started with showing many of the presentations that I have done with Kubernetes and CDF, and I decided to start with this one with Docker and containers. But I have taken the opportunity to describe it from the how let's say computing is working since the old days of the mainframe, and how the application before were deployed in one central computer, and the desktop of that computer was virtualized, or the interface of that computer was virtualized through a TTY session or through a terminal session, where these sessions are all from a central place. So they only virtualize the text user interface. Then in other, or they only share the user interface. In other, let's say, enhancement for that level of server computing, they split the load between the client and the server. So most of the processing is on the server side, and some of the processing on the client side. So many accounting applications were actually using that technique. So this application, half of it on the server, or let's say 70% processing and capabilities on the server, and 25% on the client side, where you need to install an application with a certain configuration, very hectic process to maintain. Then they came into the web era, which is started in the 1990s. So step by step, they were developing the web interfaces where no application needs to be installed on the client for the end user, but they will connect to a server instance, which we call it web tier, that is located in the data center. And because of that server instance is not actually consuming most of the server CPU and memory, so they decided to go for a sort of virtualization, isolation of this, and running many instances of applications on the same hardware. And at the same time, they need to ensure there is isolation. So they invented the VM, the virtual machine concept, the full virtual machine concept. Then today we have another approach, which is called containerization, where we have described some of it. So just to move forward, this was the text user interface of the mainframe, and this was a sample or example of a client-server application that was common to us, okay, which is the operations manager client, okay, which is doing some processes. If you don't believe me that this is a client server, it's actually a client server. And imagine also the web interface of APM or PSM or OMI. The web interface is also client server, where you have to download certain application plugin, which we call it Flash application, or application based on Flash, where they have written some code inside that Flash application, and then it connects to the server. So it takes some user input and process it locally and send the encapsulated data to the server to continue the work on the server side. This is also using Flash and Java. These are all, you can say, client-server application, but certain components, not the full application, certain components of the application are in a client-server mode. Okay, so when the first concept, or let's say the first concept of virtualization, were in let's say Java virtual machines. Java virtual machines are, you can consider it sort of isolation or isolation and containerization. It can be described where you can install the application and point to a certain JVM directory or Java binaries directory, and then your application will start under encapsulated Java virtual machine. Okay, this is also sort of containerization, if we can think of containers. Where in some situation, all you have to do is to copy the application binaries, application files and directories. You can copy it from one machine to another machine, and you start it, and it will work without any issue. So this was like early way of doing containers. Okay, but it takes a lot of time to take it, and maybe it needs some modification. So many things. So they try to control these kind of machines. Some, or let's go back for the JVM concept. The JVM is somehow control the processes, where you can start the JVM to your application that is based on Java, and then specify memory limits to that application. Like we call it JMX, maximum memory, or Java maximum memory, and Java minimum, something like that. This was control on the process, so you ensure the process cannot go beyond a certain limit. By time, they introduced the same capabilities into Linux platform. I will jump from this, okay, to the Linux platform. They created a technology called C group, control group, where you can start any process, not only for Java processes. It can be for any process. You create a control group, and then you assign for that control group a certain amount of memory and a certain amount or certain CPU sets to access and stuff like that. And then you start the process in that specific C group, so that process will be isolated, or not isolated, will be limited with these specific resources. Then they have another challenge where they want the process to start to access a specific network interface. Usually you can do this if you configure your application to point to specific IP address of your host, but you need the host itself to be assigned that IP address. So every time you need a new IP address, you need to go to the host and add additional IP address or sub interface, and then go back to your application and configuration and modify that IP address to a specific address, and so on. Also, if you want a specific host name, you need to go for the hosts file or the hosts configuration of your main machine and create everything, and then reconfigure that thing on your application. It's really a hectic process. If you can compare it, let's compare it with, if you know IIS, you can have one IIS server and you have multiple websites with different host names, okay, or each website with different host names. So this is again an isolation. For each website process is listening only when the request comes from a certain host name or a certain DNS name. This is again isolation. But they want this to be handled not on the OS level or the application level. They want this to be handled on the kernel level. So they invented something called namespaces. Okay, and in namespaces, they made many technologies or many capabilities under namespaces, where one of them is called UTF hostname, where you can launch a process in isolated mode, and this process cannot see the original host name or the hosting machine name, but this process, when it starts, it can start with its own host name. And they added the capability to have its own IP address. So they added this net one to have its own IP address. And for each process within that namespace, when the process needs to check other processes around, it cannot see any process except itself. When you launch your application will become process number 1. And it cannot kill, let's say, if your application starts with a full privilege in that namespace, it cannot kill any applications around in your host. Okay, it will not be able to see it. It cannot do anything in the main machine because it's actually the process starts as process 0. So it has no capabilities. It cannot list any external thing. Also, if you want to see a certain part or certain partition or certain disk or certain volume or certain directory, you can also say that this specific namespace can see only a specific folder, and you can make this folder as the root of that namespace. So any process start within that namespace will see only that disk. So if you have application, let's say Oracle an instance, you can say this Oracle instance starts in that namespace, okay, and it see only a certain volume for the data, for its data database and logs, okay, and it cannot access any external thing. So if, let's say, if there is a vulnerability or any problem within that specific process, it will not be able to reach the external or other folders in the same hosting machine. Okay, this without creating any virtual machines. It's all isolation within the kernel for that specific process, and so on. Also, your users within the host machine can be root users inside that specific namespace. So you can create normal users in the hosting machine, on the Linux machine, and when you start a specific process, these users will be like admins or root privileged within that namespace. So this is also a capability in the namespace. And many features, yeah, they are listed here, and we described some of them last time. And last time also I had some websites about namespaces. Namespaces MNT, like this, namespaces. So this is one of the blogs. He was describing about what is the MNT namespaces and how it works. If you need to if you want to read more about it, yeah, just to get a full understanding about the capability. But here you can see invoke namespace, and they execute a certain command, which is like a bash here. Okay, in the namespace, I think that is the namespace, maybe number. Okay, and it describes, it has a full description and clarity. There is many articles about this. You can see part 1 and part 2, part 4 and part 2, and there is also part 1 as introduction. Okay, this is for the process ID. And if you want to, if you are interested to test this yourself, you can test it. There is also, I think, lab in Google Cloud, in the docs, like the, let's say the online help of Google Cloud. They also give you some commands to test the C groups and this one, the namespaces as well. So this article is about introduction about namespaces, and it shows that these capabilities in namespace are actually introduced in these years. So you can see it's early, it started as early as 2002. Okay, so for sure, if you want to, let's say, create a package application, and this application to have his own MNT, UTS, PIEs, everything, you need to write or you need to run many commands in a right sequence to ensure that you use the full capabilities of the namespaces. And then you have to add some other capabilities like the C groups. Then you have to add other security capabilities like the SE limits and change root. So this, imagine if you want to isolate your application, you have to write all of these. Let's say any of these, let's say one command or two for each word here. So actually many commands. So this is where the concept of Linux containerization started. Okay, the Linux containerization, where some companies, so let's say some projects started to combine these capabilities together in one single command. So we go back here in this which is second article, we can see that this capability can be downloaded from GitHub, which is the GitHub for namespaces for that guy. And here it describes that just like the namespaces, and if you want to explore it, but actually you can head to Docker and LXC and Rocket or RKT. These are most, let's say, most advanced way of implementing the namespaces. So this LXC is, let's say, an organization that maintains the Linux containers. And they are telling you this LXC engine, we have all these capabilities within the engine. So, and it's actually, as you can see, is written by many languages, and all together with, you can imagine, one single command. If we go back for Docker, Docker is also a way to combine all this. To combine this, sorry, I think I lost the. Yeah, here it's Docker. Okay, or actually you can type Docker. Yeah. Not a big deal. Yeah. Okay, so which is, we can type Docker. So Docker is, let's say, the most used way of containerization today because of many things. So we will talk about them in the coming parts. Okay, so so we can say that these engines or Linux containerization engines are actually to create isolated process or isolated application in the most easiest way. Not only to create, but also to run it and to maintain it and to make it portable as much as possible. Okay, so so these are example of the container engines, and there is libcontainer, and there is LXC, and there is libvirt, and there is system mspawn one. So some companies, I think Docker also uses mostly everything, okay, or combining these engines together to make the best out of all of them. Okay, why we describe this? Because during launching of containers, we might face some issues, and these issues because of certain errors within the Docker. So if we want to understand how this works, we need to understand the background of each technology. So this was Docker and the company, and when it was started, as you can see. And then the concept of Docker is as easy as one single machine where you install Docker engine on top of that single machine. And then if you want to run an application, this application can be encapsulated with its own binaries and libraries within what we call a container. Or if we want to change the word of the container, we can use self-contained, we can use portable, we can use lightweight, we can use encapsulated process, so we can use isolated process. You can use any of these, but if you want to use all of these together, you might say container. Okay, so if you are saying container, it means isolated, it means portable, it means. Okay, so it's as you can see, it's a complete system, contains file system for your application, contains the binaries for your application, libraries, and sometimes also contains full distribution of the platform, like a Linux distribution. And because of that, container is, let's say, flexible. So we can run it anywhere. We can run it on any operating system, whether this operating system is on a physical machine directly or installed on a VM, okay, or installed on a cloud platform. It doesn't matter because it requires the operating system to host the Docker engine. That's it. Yeah. Okay, and even if you install Docker on clouds like, let's say, Azure Cloud or Azure Kubernetes Cloud or Azure Mesosphere Cloud, whatever cloud, at the end there will be a Docker engine hosted on a virtual machine or an operating system to be able to run your containers. So the idea, if we think about how this is solving today's problem, usually when the developer creates an application, they only taking care about the application coding. So they create the code, they select the language, they start coding with that language, and then they do some sort of testing. If that coding is working well in that platform, let's say Node.js, for example, as a platform, and they start using Java script as a code, and they write it in Node.js, then they have to, if they want to distribute the application, they need to ensure that this application can work on Linux platform and Windows platform. And in Linux platform, there is many flavors. In Windows platform, there is many flavors, or many versions, or many types. So they need to test it to a certain set of platforms. So for the developers, they need to go for the testing team and asking them, please run this code once in that platform and run all the test cases in that one. So actually, it's a hectic process. And it takes a lot of time to release a new product version. So with Docker, what you can do, you can create your code and you test it during the development on Linux, certain platform that you are interested in. Okay, so grab everything, wrap it up, put it in that platform that you like, and then create a container, and then put it on the cloud, put it somewhere where IT operations can download it and run it as it is, as per your configuration. They don't need to run it again and to copy the files and to do modifications, anything. They just copy it into your own machine and then run it. They run it with the same code that you have written. They didn't touch any of your code. They didn't touch any of your platform that you already built it before. And then they can run it everywhere. Only a few configuration they might do, which is like where is the files will be stored persistently, because usually the containers are self-contained. So if the container is destroyed and you start a new container, it's actually like a new instance of the application. So sometimes I need to have where will be my previous files. So this kind of thing is called the configuration. You need to specify during the startup of the application, and mostly you specify it once. Yeah. Okay. So it's actually solving lots of issues.
Can I ask a question?
Sure, go ahead.
So where is the Linux limitation here? That it's a Linux, of course, it's hosted on Linux and it's a Linux container. But when you create a container, you can create it for different platforms. But there is a limitation that it has to run on Linux, the container itself.
Okay, the Docker engine till today, the Docker engine, if you create container based on Linux, it has to forward these executables and these commands that we discussed before to a Linux platform. Okay, because actually the engine is executing set of commands, okay, and starting a process. So it should be a hosting operating system. The hosting operating system should match the container platform. It should match the container, let's say, type. So we can say Linux or Windows. So today, Linux operating systems can launch only Linux containers. Okay, that's today. Microsoft tried to do their own engine, and they didn't, let's say, it didn't go well because of the popularity of Docker. So what happened, they made the agreement with Docker to be able to create their own containers on Docker. So they use the same capabilities in Docker, same features, more than just a process isolation. There is other capabilities which we can see here, and like how the runtime, how libraries are maintained, many things beyond what I have described. So they made like agreement with Docker. So they can have Docker engine for Windows, and it's started in Windows 2016 to have that Docker engine. It's mainly running Docker Windows containers, Windows containers mainly, but there is a capability inside Windows platform to launch a Linux virtual machine as a side, on a side. Okay, so if you want to launch also Docker, if you want to launch also Linux containers, it can run on a Windows platform. But in reality, it's running on the machine, the virtual machine that was created in Windows, the Linux virtual machine in that Windows platform. So today, containers, Windows and Linux containers can successfully run on Windows 2016. But many people not interested to test it. But maybe in the future they will be obligated to do this. But anyway, it's a seamless operation. It's not visible to end user. You just start with a container and it will start to that virtual machine. You don't need to take care about anything. Okay, so it's just if we got people, actually today we have very, and let's say curriculums available from Microsoft about Docker and containerization. So for sure, when the market is saturated with good qualified operations guys, this running a container, Linux container on Windows platform will be just as easy as any other things in Windows. Yeah. Okay, so I hope that's answering your question.
So
yeah, I was about to call you, George.
yeah. So let me put it from my perspective, the way I look at it. Docker is built on Linux as, let's say, an application or an engine on Linux to leverage features that are in Linux, like the C groups, for example, in order to run containers. Okay, now that's why today Docker is an application, let's call it, that can run on Linux operating system, because it was built to leverage some functionalities that are available on the Linux and on all Linux distribution. Now, what Mahmoud was saying as well is that Microsoft approached Docker in order to do the same based on some features that are available on Windows, but forget about this for now. So Docker as an engine was developed on top of Linux, or to run on Linux and leverage Linux functionalities to be able to run containers. Now, regarding the containers themselves, when you write a container or you want to create a new container from scratch, just to give you an idea, you will need to set the operating system of this container. So you say from, for example, Ubuntu. This is the first line in the Docker, the Docker file that describes a new container. But when you say a container operating system, it's mainly libraries that are necessary to run the application that you want to provide by this container. So by nature, the containers are usually developed on and are by nature developed using libraries, or the mini OS inside the container is Linux based. And the reason for that is because Docker in the first place is developed as a Linux application or an engine. And then also because the Linux operating system can be as minimal as a couple of MBs in order to provide a fully functional application running on just a couple of megabytes of libraries or Linux operating system. So maybe later on there will be a way, or a Windows. I don't see it coming, because I don't think Windows wants to go this road to provide like a customized Windows operating system libraries or whatever to be able to develop containers on top of it. But for now, what you need to understand, regardless of what you can run on Windows, is that Docker is developed on top of Linux, and then the containers that Docker runs are usually based on some mini or very, very small version of operating system, a couple of megabytes that are actually Linux operating system.
Okay.
Thank you.
I have, since we are sharing thoughts, okay? No hard feelings, okay? I will share some thoughts, okay? First, yes, based on our experience, we usually, when we create a container, we usually specify the operating system first. In reality, this is not needed, okay? This is not a mandatory. In reality, you can start a container from just process. Okay, يعني you can say SH from the current machine. Okay, from the current machine. And if I have a host running on, let's say, CentOS,
You're 100% right. You're 100% right.
Okay.
But what I'm talking about is the containers that are actually running application, or in general, just to differentiate between Docker and Linux. Compared to Docker and Windows, or where Windows stand in the whole containerization technology.
I understand. I understand. What I'm trying to add, because we are like expanding the topic. So starting from an image is a good start, which is the main topic. Yes, we do it. But you can make a Docker container out of, let's say, a single file, okay, a single executable, okay, without loading any OS. So what in this case means that process will start from your current OS, your hosting operating system, okay? So you don't need to load additional distribution, Linux distribution, then you load your application. You can load from your existing, but it will eventually maybe having some issues, because if somebody runs the same container from another platform that does not support this, you will have some issues. So this is a point. Yeah. Let me give you example. If you are going to install, let's say, Node.js. So usually on the platform, in the Linux platform, you type, say, yum install Node.js, for example, and then you copy file, then you type Node.js space that file. Okay, these three commands, you can create container out of these three commands. I'm telling you based on I tried this, and you don't need to specify a platform before that. Okay, this is a point.
Okay.
I'm just highlighting a capability, and you can use it without calling a previous operating system. So in that case, your container will be very, very light. It just contains the app and binary. It's similar to this example, similar to the screen that we are sharing. It's just app and binaries, nothing loaded in between. Okay, no additional operating system is loaded. Okay.
Yeah, but let's say I have like a purely Windows application, like something built on Visual C++. That's not.
Yeah. Wait. I'm talking about Linux first.
Okay.
And I am agreeing with George as a Linux guy. I know Linux. I know George is not a Linux guy, but let's assume he is a Linux guy. And most of Linux guys hate Windows, and I spent let's say 10 years of my life with Microsoft stuff. So I have like heartbeat towards Microsoft. So what happened? Microsoft tried to create their own engine for containerization from scratch, full engine. Same like what we are talking about, the technologies like this. I'm not saying they have tried. They already have this engine in the Hyper-V. They already have it. And in reality, in hypervisor of Hyper-V, the VM that is the Hyper-V controlling machine is actually VM0, not OS. It's not a main operating system. Your system is booting up to a VM number 0, which is the Hyper-V machine. It's not an operating system. It's a VM on the kernel of the Windows. So it is actually a kernel-based technology. Yeah. Okay, and when you launch any additional machines in the Hyper-V host, it's actually as VM1 and 2 and 3. Not the same like when you install Windows Server and you install Hyper-V capability in Windows Server. So your Windows Server is the main operating system, and any machines are actually a virtualized machine in the main operating system. But for Hyper-V, it is your Hyper-V machine is actually a virtual machine inside the Hyper-V host. So going back to the containerization, Microsoft has agreed with Docker long ago. They announced it just in 2006, but for long ago they working on applying all capabilities, all imaging capability, all image layering capabilities, all that in Windows. So let's say 2 years ago, I have created the containers in Windows, and there is already image in Windows 2016. There is a Docker image for Windows 2016, very light. If we just go for Google, Windows 2016 Docker image like this. There is a server. It's called the Windows Server Core, and there is, I think, another thing, and there is here a full description. So there is a very light operating system for Windows images. I'm just sharing this to you, George, because I have tried to create operations bridge agent on Windows to be on Docker. Okay, I started this long ago. I was trying to install the agent binaries on that platform, but unfortunately it uses some capabilities that requires a real Windows machine. Like it requires a real registry, some data in a specific place in the registry. So when I tried to create a Docker image in Windows and install operations agent on top of that myself, not the developers, okay, I found many data is missing. Yeah. So it was a problem. Yeah. So they call it nano server. Yes, that's the expression, not core. The Windows core is famous expression. It's for containers, but the machine that is used for containers as a base for Windows is called the nano server. Okay. If you use core is, let's say, 2 gigs. Example, I'm just telling you for example. Yeah, it's like 2 gigs, and nano server is like 800 MB. Let's say something like that. So the core is already introduced long ago, but the nano server is the one that is introduced as a Windows container image, a real image. Yeah. So, and it's very light. Yeah. I mean, in the sense, not 800 MB is not light, but I mean it's lighter than the core, Windows core, and lighter for sure than the normal Windows editions. Yeah. So you can do it. I also installed the Node.js in that, and it was it's working. So for example, if you have an application that you installed before in Windows Server Core, let's say a DNS server, Windows DNS server that runs under core, you can create a Docker file, and then you can say from Windows Server Core, and then you add your lines that includes libraries that you want, and then the command to run your machine. This, for example, is Node.js application that was tested in Server Core. Let's say at that time of the writing the article, there was no Node.js that works on the nano server. okay, because certain libraries are missing from the nano server. So in that case, if you will include nano server here, you need to add some lines to add the libraries that are missing, and then launch your machine. So anyway, Windows, they did a great job. You can see here in the Windows and Linux, control groups. Yes, we have control groups as well in Windows. We have namespaces in Windows. We have layering, which is image or file system layering capabilities in Windows. So great thing. And we are actually using the same techniques of Docker engine. So I would say they did a great job. And also it has a capability that is not there in Linux, which they can launch a virtual machine of Linux and then launch, and Docker engine is able to communicate with the virtual machine of Linux and launch your container in that one. Okay, so these I'm just sharing the capabilities because many of you are not Windows guys, and even till today in our team in Micro Focus, they are not interested to make anything of Windows on Windows or any container on Windows because no need. In reality, till today, all their problems are solved, or let's say the problems we know, they are all solved under Linux. So they are, let's say, happy with Linux containerization so far. So that's my input in that regard, and I hope it's useful for you.
Thank you, George, and thanks, Mahmoud. Very good answers. Thank you.
Okay. And again, if you think that we are going off the topic, please accept my apology. We are not going off the topic because you, as per the introduction, my expectation is to give you a solid background on the three items that we have in our topic. So I think this is related to that one. If you have different feedback, you can share with us after the meeting. Share it with me, share it with George, and then we can enhance it next time. So let's move forward. Okay. So we are still on the same slides that we have described last week, but we are going into more details. Okay. This slide, it was about the lab that we have created for the Docker. First thing we said about Docker, all you need to do is to, you can go for hub.docker.com and then you create account for yourself. This is really important and needed for everything. And as you can see, this is my account, and this is my username, and I have access to these images. These images I have created myself. Some of them for Minecraft. How to have Minecraft with Docker and Kubernetes. Okay, and this one is Hello World image. It's called the Friendly Hello. Very crazy name. And it's downloaded 92 times. So you might think this is a very famous application, downloaded 90 times. Okay, this is not true. This is only me. I am the one who downloaded it 92 times. But this is how it's used. If you see this under your organizations, you see Micro Focus, it means you are subscribed with your account to get Micro Focus images. But if you don't see this, you need to send the email to a certain group. It's described in the guides to be able to download the latest ITOM images. So the latest ITOM images, if we click in this organization, we can see it here. All right. So this is mainly the, so as you can see, that these are the images that's related, or this is actually teams, and under this teams we can see images. Okay. So this is, you can say, the starting point. Another starting point for Docker is to access docs.docker, and you go for the get started. Okay, and here it describes how Docker is helpful, okay, and how it's scalable, portable, and stackable, and so on. So the first thing that we need to do here, okay, to move forward from last week, you can run any containers available by the command docker run. So if you install Docker in your machine, you can run any container by this command. So if we go here in this machine and we type docker, clear docker run, and then we can type hello world. Okay. So Docker run hello world. What happened? The system tried to find this hello world in the local images, and what happened? It's not able to find it locally. So the system tried to pull it from online, from the hub.docker.com, and in that case, it's actually downloaded, and this where the Docker started, or the container started. So we can see here that container started and showing us a message called hello world or hello from Docker. Okay, and giving us some messages. Okay, and here if you want to continue, go for that URL. So you can start by this one. This is downloading images. If you want to see the images that are already downloaded, you can type docker images ls. Okay. Really good. Okay, Docker image, only image, ls, and you can see here there is hello world that is in my machine. This is hello world. Okay. If we want to discuss about the what are these images, simply to compare it from the operations point of view. There is in Linux, you can get images, you can get Linux machine that is running from a CD-ROM, or a Linux machine that is running from a USB drive. Today also we have the same for Windows. You can launch, you can start your laptop from a USB and you have a full working operating system. Okay, so these images is similar to that concept where you have encapsulated OS or encapsulated application within a file, same like ISO file, same like let's say appliances in the virtualization, in the virtual machine concept. So we have image file, and then you link that image with your virtual machine in a virtual machine world, and then it's called the VM1, it's called the VM2, it's called the VM3, and so on. But in reality, in Docker, when you type Docker start, when you type Docker run, last time George told us to type -d, I think, right?
Yes,
it's running in memory.
It should be.
Yeah, it should be running in memory, and it's giving me a very big name like that.
ID.
But anyway,
ID.
Yeah, it's like a full ID of that machine. So if we type docker ps to list all the running containers, so we can see lots of containers are running. But let's say that every container, when they run, they have a Docker ID, which is a small set of this ID. It's here, and this the image name that is loaded from, and then the actual name of the container, or the container name, and what is the command running, and when this container created, and what is the status of that container. Okay, and that's it. Yeah. Okay, so it should be one of these. Should be related to hello world. For sure, it's a big one. So we can type grep hello hello world. Okay. Okay. I'll tell you, George, the reason if we couldn't find it, that it's actually is not actually making something to load in memory. Okay.
Yes.
So
the hello
world specifically. Yeah.
No, my hello world. It's doing running a script to print hello world, and then it will exit.
And then
so this is what.
Yeah. Yeah, that's correct. So what we can do, we can type -a, which should give me like historical information. You can see here there is many things that are exited. These are historical one. The container are not running anymore. And then we can type grep hello out of them. So we can see that there is containers that were running. The first one that we launched 4 minutes ago exited. And the second one, which we launched with -d, also exited, because actually there is no command except you can see a command called /hello. What we can do, we can, I think, run with a command. I think, I'm not sure if we can do this, like bash. I don't know if this one will give me that capability. No, they don't have. Or we can say exec okay. Says don't tell me anything like this. Okay. All right. Okay, so actually like we are doing not a good thing here. So we'll do something differently now. What we will do, we'll actually create a new container from scratch that will have application, and that application will be based in Python, or a website that is actually based in Python. So to create a container, all you have to do is to create a file, and you name it a Docker file. Okay, so your starting point for creating a new container, for sure you can make a new directory called thoughts. Then we create file such the Docker file. Then if we type ls, we can see there is a file called Docker. Then we can create a file from scratch, and we will follow George's strategy. Let's see. George said that for Docker, we need first to start from an image, previous image. So yes, we can do this. We have an image called Python, and it's version 2.7, and it's a slim one. So what we will do now, we will go for this one, and insert that line here. Sorry. Okay, we will insert that line. So we will create new containers, and its base image will be from an image called the Python 2.7, which seems like an operating system that is already loaded with the Python. Okay, and version, it's actually Python 2.7. And what we will do, we will run in that container, install some libraries that coming from a text file. So this is actually the, let's say, the second or the step number 2. Okay, but actually what we need to do is what is the file, what are the let's say the libraries. So actually this is the file is called requirements.txt, which is equal to that one, and the file the libraries called the Flask and Redis. So what we will do, we will exit from, we'll quit from that file. Then we will create the file that is called the requirements.txt. This is just how, let's say, developer can build their own application. So now we have requirements.txt as a new file, as you can see here. Then we will have these two lines added to that file. Insert and then add these two files, then we exit. So if we go back to this command, we can say now if we launch this, the system will be able to find the two files. Okay, so go back to the presentation, the slides, or this one. What we need to do, we will run a command Python, and the file is called app.py. So this file is actually a Python file, a Python script that loads certain libraries from the Flask library and from Redis, and it imports some other libraries like OS and network sockets, and it creates a web page that says hello, and it gets the name of the variable called name, and says host, and then its host name of the container, and the visitors, number of visitors, and there is some coding here. It's a big story, but don't bother. So what I will do now, I will copy this and go back to this part. Quit. Then I will type vi-app.py. So I will create a new file now, and then I will insert all these lines into that file. And as you can see, it's Python will, the Python application will launch this website on port 80. Okay, so going back to that guide. So now we have these two files, this one and that one. And here, what we need to do, we need to copy these files into a certain directory. Okay, so what we'll do here, we'll say like this is copy dot into that directory. Then you can set like the work directory for my application will be this directory. And then here we will expose port 80 of the container to the world. And then we will make environment variable called name and the value equal world, and then the command. So what I will do now, I will use this part, all of it, into my Docker file. Then I will insert it that way, just to save time. This has, yeah, for sure, you know, this hashing, this commenting, not a big deal. So the second step is to build your application. Okay, so you type Docker build, and then you can give a name of that build. So Docker build, and we call it thoughts. So we will create image now, and that image will be named thoughts. So what happened with this command, it will look into the current directory, and it will try to fetch the Docker file, and based on the Docker file content, it will try to build an image for Docker. Okay, and you can see here it says Docker build. Yeah, they should be like dot. I think. Okay, why is dot is at the end here? Okay, all right. So Docker build dot. Okay, so actually it's like, let's see it there. Okay. Sending build context to Docker, response from daemon, unknown instruction. Okay, so it seems like there is something wrong with the binary, with the file. Okay, so here this line starts with E, and they don't have a command called E. Okay, so it seems like I did not copy it well. So let's do it again, and this way. So what happened? First step, I try to pull the image from online, from the hub, from image store, from a place where these images are located. By default, it pulls this from from hub.docker.com. And here, what happened? It created this image and stored in image in the container, a layer called this is the layer. Then that command, it's stored into another image layer. And then that command is stored in another image layer. And when we try to run this one, it's actually in reality, the VM started, and this command is running under that VM, this VM actually, and it tried to get this command executed. And what happened? Because of firewall, okay, or let's say our current configuration of this virtual machine, it was not able to reach that website. Okay, so it's actually failed to access. So the whole script is failing. So what we can do just to solve this as fast as possible, we can go for that Docker playground and fix it. The other and create new instance and configure it. The actual way or the right way to do this is to specify your proxy settings. If we have a proxy setting, we can specify the proxy settings for that machine, and these proxy settings will be considered during the next step, and it will be able to get the data. We can do it this way. So what we need to do, the proxy setting is actually an environment variable. Okay, so before that, I would duplicate this to get the proxy settings. Set. Okay, so proxy is not set in this. Okay, so history. Grep proxy, because I'm okay. All right, so this is a proxy that I expect, and this is the environment variable. Okay, so what I will do, I will use that information here. And try again. Let's see. So it tries again the image, but now the image is already presented. And this is copying, and this is the PYP install. Okay, and it tried to connect, and it's still failing. Okay, so it's not successful in this case. Okay. Okay, VI. Okay, so ls. Okay, cat Docker. Okay, see here it was working. Okay, so it needs somehow. Let's try these two things, 2 lines maybe. Okay, maybe the format itself not well. Let's see. So thoughts. Let's build the game. It didn't go well as well. All right. Okay, so I don't know why this is not working. Maybe I need to. Okay. Good. So we have a new platform or a new machine that is actually connected to the internet, and everything is ready. And I will show you the portability concept now. So ls and then make dir thoughts, then vi docker file, then insert, and we take all this stuff. For sure we will remove the proxy. Okay, so insert. Okay, we already inserted. Then here we will delete these lines and save it, and then vi okay, vi requirements, the text, insert. We will add these two lines in. Okay, then the Python file, I think, cat fp. So cat, okay, vi.py, insert, and these are the files. Okay. So what we have to do now is to write the same command. Okay, there is a command that was failing before, if you remember. The thoughts command. Seems like thoughts is actually a bad word. It's not. Has a curse with them. Okay. So now we are doing the same on a machine somewhere. So this is the step where it failed last time. Okay, but this time it seems to be successful in a way or another. Okay. It's like something like installing libraries. For Python, it's pip, and for CentOS, it's yum installer, or for Debian, it's apt update, apt libraries. So it's just adding libraries that matches with that specific platform. And we are about to finalize it. Okay, and this is the command pyp, and now there is an image tagged in this machine. It's called thoughts.latest. So if you type docker ps image ls, we can see that the image that was downloaded, which is a Python with that tag, and the new image, which is thoughts, which is just created, and the size is 131 MB. This is a sample of a developer building his own application. If we want to test it in our platform, we need to push this image into the hub. So I will type docker push this image. So I'm typing docker push this image. So it says request denied because it's a file that will be uploaded into Docker Hub, and Docker Hub don't know where to keep it, under which name. So I would change the tag docker image tag, I think. Yeah, docker image tag, and then change the tag from this tag to my account / this tag. So what happened? I just give it a different name. So what will happen if we type docker image ls? What you can see, there is a different tag for the same image. Okay. So in this case, if I try to push it again, let's see if it will work or not. But I'm saying put it under this account. Okay. Let's see. It uploads and then access denied. Actually, why it's access denied? Because I did not give permission to anybody to upload images into my place. So what I will do now, I will type docker login to allow authentication with my system or with Docker Hub. And then I will type the password. So now this machine has successfully authenticated with the Docker Hub. So in this case, when I type docker push, so you can see here in my Docker Hub account, my content like this. We have only few images that are just being loaded now. Oh, sorry. Okay, not my content, maybe no content. Yeah, just this page. You can see MH Ibrahim, and these are the images. We don't have floats here. So going back to this one and then push it. And now there is a pushing process started. And what you can see here, it says that this image, the image is actually multiple layers. So we have one layer here, second, and these are the extra layers that we have created. It says that these image layers are actually available inside Docker. So they will not push it again. It just reference the ID of that image in my place, and that's it. If we go back to this place and we just refresh it, we can see the thoughts. Okay. So what we will do now, because we already started the lab in our machine, which is this machine, the one that we couldn't make the build because of the network scenario. What we will do, we will type docker pull, not push, pull mh Ibrahim / thoughts latest. So in that case, we are now pulling. See what happened. Also, when we try to pull it, it says that these three layers are already existing because we already pulled it before. Okay, we pulled already the Python parts, which are actually in these layers, and these are the three new. So the system is intelligent enough, or Docker now is like intelligent enough to pull only the missing parts of the Docker image. Okay, so now if we type docker image ps in this machine, which ls. Sorry. Okay, we would see we have mh thoughts, which is created online 5 minutes ago. So here we can know which the images that we download, when it was created or updated. Although we just downloaded Python today, but it says like it's 8 days ago. So this image is actually updated 8 days ago on the Docker Hub. So as you can see now, Docker was able to package an application and put it online, or you can push it somewhere on a hub or an image store, and then you can download from the image store to any machine, okay, in case if you have issues like the one we have faced. So going back to the lab, okay, so we have the image now. Okay, so here it says because of the proxy settings, you can follow these steps. Okay, actually it's not working because it seems like the proxy server I have is expired, is not valid one. So that's why it's not working. So anyway, what we can do now, we will run the machine, the virtual, let's say the image that we have created, the Docker container. We will run it, and we will expose port 80 from the container to port 4000 in the host. So I will take this part, and since we have created, it's called, today is called the Mahmoud MH Ibrahim / so this is the image name today. So what happened? In a container now started in memory, okay, and it's loading the library, which is called the Flask, okay, and it shows some messages related to, let's say, Python, okay, and the code, it seems to be and what we need to do to test is to check that IP address and port 440. Let's test it here. Okay, so I typed HTTPS while it's not S, it's not S. What we can see now, the world, the hello world message, it's bold, I think, as per the code that was here, that the, yeah, hello and the name is actually header 3, and then host name is bold, and the machine name will be not bold, and visitors and stuff like that. So anyway, so what happened here? So host name and the machine, and this is the host or the instance now. All right. What happened on the backside? It seems like client is trying to access. He sends like HTTPS, and the system said like bad request. Then again, he tried to access with normal HTTP, and the page was accepted. But it's also during the loading, the system was trying to get something called the favorite icon, which, you know, when you are accessing the YouTube, you can see this icon on the YouTube, or this ITM source icon. This is automatically the browser is trying to fetch that icon, or this one. So we did not load such icon here, so it gave it 404. Anyway, this is image and loaded, and that's it. Now I'm exiting and type docker ps to see if that image is loaded or not. Grep thoughts. Oh, thoughts is like everything. Okay. Latest. Okay, so the container is stopped already. -A. Yeah, so the container was starting with that image, and it's loading the Python app.py command. It's 3 minutes ago, and it's exited. So Docker, so Mr. George told us yesterday that we can type a command with -d to ensure it's running on the background. Okay. So we will do it. So actually it's running on the background, as he mentioned. So now if we type docker ps-a, it will show there's 2 containers. This one is exited already, and there is another container that is still running, and the port 4000 is there, and the host is not F74, it's 029. So what we can do, we can refresh this one, and you can see that the host is updated. So this is part of the Docker story. George, feedback, additional inputs?
Nothing to add from my side, Mahmoud. That was really good.
Okay, great. Well, I'm really happy that you said that. I thought it's boring for you.
No.
Okay. What I can tell you, more than this, visits, and here cannot connect to Redis, and the counter is disabled. Actually, this gives you a counter of users, how many visitors are visiting your website. But let me show you something. If I want this website to be loaded 2 times, I will run it again like this. But what will happen? I think it will fail. It will not succeed. Okay, so there is an error happening because the endpoint is port 4000 is already allocated. So I cannot run 2 virtual machines to the same port. Okay, for sure, that's common. I mean, that's very famous. So if I type 1, so I have now 2 machines. Okay, one is, oh my God. Okay, let's see what's happened. Why is this? Okay. But why is it already in use? Okay, I don't know. I really don't know. But let's use 2. Okay, so now it seems like it's running. So we have in 4002 and 4000, they are already two containers are running, 2 applications running on the same host without any challenges. So if I change 2, it will change. Okay, do you remember that previously when we launched it before adding George's command -d, we were able to see some log data. You remember that? Okay, so what we need to do now, we want to know what's happening in these containers. So we can type docker logs, maybe it's logs, and then we specify the container name or container ID. Let's be more specific. So this is the container ID. We can see that the data that was displayed before is actually running on the background somewhere. And let's see if we can get some help if we want to keep it in a follow mode. So we can type -f. This is actually the container that is running in port 422, something like that. So what I will do, I will type / okay. So I type /George and they give me page not found. Okay. So what I will do now, tracing. Okay. So here somebody is trying to access /George and it's a 404. Okay. So Omar also. Omar is 404. So it seems like we don't have anything except app.py. But let's try. I did not try it before, but let's try app.py. I think it will not work as well.
Sorry, Mahmoud,
Yeah, because
I was on mute. Excuse me.
Yeah, go ahead. No, I just giving the names. Actually, the PY is not a web. It's not a web code. It's actually the application of Python. So you cannot even call it from the HTTP. So now we had issue that if we want this application to run on many instances on the machine and to listen to the same port, this cannot be achieved. Do anybody has a solution for that? George, you have a solution?
Sorry, I missed the question.
Yeah, we want to access one port and then we reach to the two containers or to reach to any of the available containers.
The same container running twice?
No, yeah, it's two containers, like now one in 4000 and one in 4002. What I need to do is to have like port 5000, and when I connect to port 5000, it forwards me to either 4000 or 4002. So you need a solution. Okay, so
you need the proxy.
Very good. So what George mentioned, we need the proxy to do this, right? I think everybody agrees on that. So there is a famous proxy that I don't know how to configure it to satisfy the requirement. Okay, there is a famous proxy. It's called Nginx. Docker. So Docker, we have many commands, as you can see. Docker, there is Docker search, right? Docker search. Okay, Docker search for the word proxy. Let's see. It says like we have many proxies. Okay, so we have here a proxy with SSL under Mr. Daniel Dent. Okay, so he had a proxy where we can get it and we can configure it in a way to forward to the containers. I don't know if this is true or not, but we need to visit this guy and to check what is this container and how we can configure it. Okay, but now they give me an idea. There is something common across most of the containers. It's called Nginx. This is a famous container name, famous proxy, that if we search about it, we can see there is a container from a company called the Bitnami. Okay, and there is in many places here. So this is a generic.
Mahmoud, I have a question.
Okay.
Have you seen Nginx and working, and where? Or to everyone, anyone knows or heard about Nginx and Nginx and the PS where?
Okay, I will.
Mahmoud, let's see if Ahmad, Samah, anyone?
Jinx, you're talking about Jinx?
Nginx, the proxy that Mahmoud is talking about.
Oh, okay, no, I didn't hear of it.
You didn't hear? Okay, Mahmoud, go ahead.
Okay, I'm just using the time. Okay. What other proxies that you heard about? We can find another one.
No, Mahmoud. What I want.
I know your direction. Yeah. I know your direction. I know this. I know what you meant. Okay, I'm just asking a question. Maybe F5. A famous proxy, maybe.
F5.
Yes, of course.
Yeah. Okay, there is F5. Okay,
yeah.
So yeah, it's famous as well. So it's now
there is also there is multiple proxies that can be used now. For example, HA proxy and Apache they have, I think, also a proxy. But from my perspective, Nginx is one of the most mature, specifically utilized in container environment.
All right, yeah, this is the one. Okay, and let's say
من وين عم بيقرا الداتا سورس تبعه اذا
يا احمد مش كده احمد داخل من لبنان تغلس علينا تمشي مش معقول كده ماشي اوكي all right yeah the what George was saying that it's a proxy service it's you can see here there is a proxy service called the HTTPD or this is the HTTP daemon for Apache. Okay, there is a Cassandra. There is many projects here from Apache. I mean, it's the point is we have an issue, or let's say we have an issue, which is we want to have two containers in a high availability mode. In reality, we cannot have one fixed port to solve to be appointed to two containers at the same time. So what we need to do, we need to have a proxy, and proxy can be anything. Okay, can be F5, can be Engine X or Gen X, whatever the way they call it. Okay, but anyway, it's you need to add a solution, and what we can see here in a few seconds, we can grab any of these proxy images, and we can configure it. It depends on the knowledge that we have, and then we can apply it. Yeah. So there is sometimes you look here for the stars, and you can see here in the Engine X, stars is like 10,000 stars. So it seems like Engine X is really famous. Okay. I don't know here. If you look to other stars are not that much in anything else mentioned. So usually what the developers are doing before going to read any of any of these images and how they are working, they usually look for the rating, and they look if it's official or not, somebody supported or not, and based on that they will go for that one. Okay, so at least start studying how to implement with their solution. So it's just this is what I'm trying to say, that you can have this. What also we are missing here. I was telling you that we have in this page. Let's go back to working page. Yeah, we have here a problem saying that the visitors number is not showing because the Redis, we cannot connect to Redis. Okay, and that's why the counter is disabled. So in reality, if we read the code of the application here, they said the visitors, it reads from variable called the visits, and actually visits is actually coming from Redis.incremental, and Redis is actually connecting to a host named Redis, host machine named Redis, and it try to get the counter from there. While in fact we are not loading Redis. Yes, here we have import Redis, but Redis here we import as the coding, as to be able to connect to a counter. Redis, imagine it's like a database where you store keys and values. So it's like you store a visitors, and you give it when first connection, you store 1. Then when there is a new connection, you store 2, store 3, 4, and so on. And then you display the number to in the website. That's the main idea of Redis in this case. I mean, in this coding. Yeah. But because the container is not loading Redis, so we have an issue. So what you can do, you can get you can create another container for Redis, and then specify the container name here or the port number or whatever in that one, and then in that way the hello function will try to get the counter, and if it succeeded because of the connection successfully, it will show you a number. If it fails, again it will show you that cannot connect to Redis. That's what I meant. And here also hello and name. A name is word based on the variable. So you pass a variable called the world, called the name, and in that name you give the word world, so it will be hello world. So what we need to do now, we need to tell Docker to take another variable. Don't take the same variable. We want to give different variables, or we don't want to pass variables to the container. It's quite crazy, but let's say Docker run dash help. Oh my God! You can see here we have many parameters. Okay. There is a CPU count. What do you think about this? Any feedback? What is a CPU count?
I cannot read it. What does it say?
CPU count.
CPU count. Oh, okay.
Okay.
It's a number of core CPUs that's available.
Yes, it's like number of cores. So I will start the containers with control on the number of CPUs for that container, right? You remember we had discussion about C groups, right?
Yeah.
So this is like a C group parent. There is a cap capabilities. There is a limitations, quotas. Okay. Yeah, there is many controls that you can have, and there is. Go ahead, George.
No, I'm saying so. Those parameters are critical and a must for example, for any production environment, because eventually, imagine that you are running tens of containers on host, and you are not specifying how much the memory or the CPU is being distributed.
Mm-hmm. Yes.
Yeah.
Right.
Yeah.
And once you create a container, you cannot go back and modify it or add to it, like let's say CPU.
No, you can modify. You can modify it. You can modify. Sometimes not everything, but you can modify things.
Mm-hmm.
But better than modifying, you can just terminate it and create new one with the new configuration. It's much easier because the container is not something that is stateful. It does not have a state, a specific data that is related to the container. Mostly the data is like outside data. Okay, so they call it a stateless, and it's not storing anything within the container itself. It's storing everything outside. So it's much easier to terminate it and create new one because it's just a few seconds, as you can see, and you get a new container up and running. Okay, but what I want to say here, we have the -e to set environment variables. This -e. So what I would try to do now. Okay, once again, I will expose this one in board 4003 and type -d, and let's say it's called name, I think, or name ABC. Let's see, this what? I don't know. They say starting causes problem, blah blah blah, -d. It's not found on the bash. Okay. It seems like they want it in the beginning. Okay, so no. Okay, so yeah, sorry. I typed -d, not -e. Okay, -e, name, ABC, maybe. I don't know if it will work. Okay, so I will go back here. All right, so this is curl blah blah -d -p, then login, upload, part 2. Okay. Okay. Docker in Docker environment variables. Okay. -e. Okay. So this is how inside. Yeah, it's equal. Something equals something. Okay. -e. All right. So if we go back to the word so it's a name capital. Okay. So name okay. I will type it here. I think -e name ABC. All right. Okay. So it is okay. Fine. It's just running. Okay. Ignore it because -d I did not make space, so it's just running. It's now the name is APC-D. Okay. So anyway, so I will check. Okay. So the name is not overwritten. Okay. 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 So yeah, because of equal. All right. So now let's start it again. So let's check. All right. Okay, you can see now that the variable it changed, right? The name variable changed. It's hello APC-D. Okay, so this is typically what happens here. It's getting the name, okay, from the variable called name. And if the name is empty, this will be the default value. That's it. So here, this is getting the variable name from the environment called the name, and this is like a default value if there is no value set for the name. So what we say now that this container, okay, it's type Docker ps grep floats latest. Okay, so we have this container is running now. So Docker exec and -ci sh. Okay. So what I'm doing now, I want to get inside the container and see things from inside the container. What are the contents of that container? So what I'm doing now, I'm telling Docker, please put me inside the container. If you remember the C groups concept, okay, the namespaces concept, that we create like a namespace, and the first process is started in this namespace in isolated manner. Okay, so what I'm saying now, I'm saying please run shell command, sh command inside the existing container, inside the existing namespace. So if I type ps minus e, okay, if I type ps minus ef, okay, ps, okay, there is even, okay, no commands within that, anyway. Anyway, if I type just ls now, Okay. Perfect. Okay. All right. Okay, since this image is like Python image, some commands are not already available in that image. So a command like ps is not in the library for that container. So that's why the command is not working. And since I connected to this command with the sh, so now what happened? I told the Docker, please execute a command called sh inside the container. This is the container name. Yeah, like asking to jump inside the container. So now, when I type host name, I can see a host name, which will be matching with that host name here. Okay, so this A65, it's A65. So this is the host name. If I type command set, this is actually the main reason I'm here. So I can see that the variable name is set to ABCD, the text that we specified in the startup of the container. Okay, so this is actually a way that you can tell your application some information. You just pass it as environment variables, and that environment variables will be used in the application to connect to specific things. So for example, if this application requires a database server to connect to, and I have my own Oracle server outside, and I have IP address for that Oracle server, and port number and database name and username and password and all that stuff. So what I can do, I can send all these information as environment variables with my container. So in the coding of my application, I will configure it to call these variables to know where is the database. So imagine this application requires to connect to a database server. So all I have to do is to start the container and specifying the database server name and the IP address and port numbers and connection details, all of them as environment variables, and configure the application when it starts to retrieve this environment variable and to print it out as needed. Yeah.
And the host name is the ID, the container ID, right?
The host name usually, yes, is the container ID. Yes.
Okay.
Okay, and also this machine has IP address, but I don't know if config is there or not. But actually, this machine is also hosting additional IP address. You know, like VMs. When you start a VM, each VM has its own IP address. It's the same exact situation in Docker. It has the separate host name, has separate IP address, but the provider of the IP address is the namespace's IP or the namespace's network that provide the IP address. So I will exit from that container. I was just telling you the idea. What I want to say, if we type echo, okay, like let's say I am setting DB database name, or let's say database server equal 110.0 or .1, something like that. And I want to use a file or to configure a file to connect. That file will be, let's say, a database connector file, okay, or db.ini. So what we shall do in that case, we shall say echo I think like this, DB server into a file, or let's say database server equals into a file called connection.ini. Okay, so if we cat that file connection, Okay. DB server. Okay. Okay. Without set. I think set requires space between the variables. Anyway, so what I will say, this is I will make it this command. Okay, so what I want to say here, as a developer, when the developers were building an application, they want to make the application flexible as possible. So what they can do, they can go for the Docker build file, and they can say every time you start the container, okay, you you do this command. Sorry. Okay, so it's echo DB server, or let's call it server, equal to DB database.ini, anything, just. Okay, so what I will do now, I will build the image again, but in this time I will overwrite the existing image. Okay, so I will name it image like this. Do we have a better way for doing this step, George?
Sorry, Mahmoud,
no, I was telling.
Yeah.
No problem. No problem. I
Go
was
ahead.
Just showing that. I was just showing them that how developers are passing information to containers. The idea here is to create variables within the container, and then you run commands to set up your container with the right data based on these variables. So, for example, it will create a file called db.ini and store a variable called db server. So every time the container starts, it will type echo and server, and it will add this information to the db.ini file. Okay, that's my point. So what I was
from
asking,
external variable from external files, you mean?
It will write it inside the container, but from a variable called db server. This is the external variable. Okay?
Yeah,
or this is a variable that we have to specify. Okay.
Yeah.
So
you're specifying within the Docker the container Docker file to copy this external variable and give it or assign it to server, for example, right?
Yes.
Okay.
But my question to you, that what I have done is I edited the Docker file itself and added one more line. Okay, and then I will rebuild again. Okay, my question is there a way better than that to do the same job? That was my question. Okay.
I'm not sure if
Okay.
there is a way to append, for example, a command to append directly a Docker file instead of going into it.
I will show you easily. There is a way, you know it already, but maybe it's not in your mind now. But I will show you this Docker file 2 as example. Okay, I will vi Docker file 2. Here I specify the image is called the Python. So what I will do, I have already image that is famous for me. It's called MH Ibrahim, and it's called thoughts, and then latest. So what I can do, I can remove everything, because these jobs are all done in that image. I don't need to rebuild it again. What I'm saying, that use that image, which is MH Ibrahim, and then add one more layer on top of this image, which is called echo this. So what I'm saying is that if somebody built the image with certain commands, lots of commands, and you want just to make a modification on top of this one, what you can do is you just, from this image, create your new container, add whatever you want, and then load it again. Okay, that's all my point in this.
Now I understood your point of view.
Yes, exactly. Same. If you remember yesterday we tried or last time site scope, which was Micro Focus related site scope. This is Micro Focus related site scope, and if we want to use it, we just can bullet this way. But what if we want to add things on top of this one? Let's say if we want to update it to the latest site scope. Okay, so what we can do, we can call that image first, then do some commands on top of that image, and then create our own version of that image. So we are not obligated to use the standard image as it is. We can build our own images from any existing image. Okay, the idea which I was trying to tell you about the variables, that if you look for something like OMI, operations bridge, in any of these applications, I will just reconnect here to OMI environment. I will use the Kubernetes command, but just for your info, nothing more, and we're just jumping kubectl get pods dash n one. Okay, so I have here OMI server, a container called OMI. If I'm logging to that container, okay, with the Kubernetes, not with Docker, which we did not have it yet, but you can imagine it's somehow similar. It's the same exec, same I think dash TI, same that name, then dash C maybe, container OMI maybe, I'm not sure if this is working, and then bash or sh. Okay, there is, okay, in dash in. Okay, so now I'm inside OMI. Okay, we just massaging the command a little bit to be Kubernetes. Okay, which I don't think it's a big difference. But if you type set to see the variables, okay, sorry for that. You can see here how this OMI knows where the UCMDB is, just because of these variables. So where is the UCMDB host? This is the UCMDB host name. Where is the suite details? Where is some other client data? Okay, integration user for UCMDB. Okay. Some other, you can see many variables are defined here. Right, you see it. Here is BVD data. So what I want to say that for containers to be stateless, okay, or to be able to reach outside systems without every time you need to compile new image, you can make a simple image and make everything within the image based on environment variables. You call the environment variable, and then this environment variables are loaded within the virtual machine, or within, sorry, the container at that time. Okay, so everything you define for container is actually based on environment variables. You just add your inputs, and in the container, in your application, you find a way to pull these environment variables into your application and use it. So you can easily run the same container in any environment, with any customer, okay, on any customer or in any platform or in any system, just to specify the parameters for these environment variables. But I feel that some of you have seen the environment variables here are quite challenging. It's a very big list of environment variables, right? Anybody sharing me the same? Ahmad Muafi? Okay. So there is many environment variables, I think it is. So what we can do to solve this issue, we can try to create an environment variable file and pass that environment variable file to our container startup script or startup command like this. Then based on that, it will load all these variables. But what if these variables are needed across different containers, across different hosts? This where they have Docker themselves created something called Docker machines, or let's say a clustering technique for Docker, where you can have from one machine, you can run the command, and this command will run across many machines at the same time. Okay, so you are setting the configuration one time in that place, and then that configuration will be pushed everywhere. Okay, so then sometimes you need to be able to specify how many instances, how many Docker containers to be running for that application. Okay, so you want like high availability, some clustering capabilities. So you might need a tool on top of Docker, okay, to orchestrate the work between multiple Docker servers. Okay, so Docker as a company, they offered something called Docker Swarm as a manager for multiple Docker hosts. Okay, so from Docker Swarm, you can run the container with a single command, and that container will be pointing to multiple locations. Okay, so the complexity for, as you can see now, we every time we talk about containers, we talk about the Docker images and maintenance of the images and storing them. You have seen like things are getting complicated step by step. So we created the image locally, then we pushed that image to a remote registry. Okay, then we pull it back to another host. Then we run from that image multiple containers. So this kind of complexity needs a better way to manage it. I cannot like run many commands. Same like what the beginning of containerization. They have many commands for namespaces, many commands for C groups, many commands for this. So they want to centralize all these commands into one place, which will be a Docker command, Docker run, that's it, or Docker exec, that's it. Okay, But sometimes you need to run this command many times on many hosts. So you need like a manager of your Docker hosts. So this is where you go for a clustering solution or orchestration solution. Okay, just 1 second, I'll just check if I have something like that. Okay. Okay, so you might need something more than just starting the container. You want to know, you want to start the container only on the servers that are having enough resources. If I'm managing multiple servers, let's say 5 servers, 10 servers, and they are all having Docker engine on all of them, and I want to start a container, I want that container to run on the most free host machine. So I need somebody to be responsible on scheduling of the container on the free host. I want something to ensure that that container is running healthy way, in a healthy manner. I want to ensure that if it's failing to start, after some time, it should be rescheduled on another host. These kind of capabilities are challenging capabilities, which led to the companies like, let's say, Docker, to create another solution on top of Docker, which is called Docker Swarm. And led also Google to create a platform called Kubernetes to solve this issue. And I think Apache, they are the ones who created Mesosphere, as far as I remember, yani. They also created a way to run multiple containers or containers on multiple hosts with a tool called the Mesosphere. Many tools are available in the market. Even me and you can create their own tools to handle how the containers are running across different hosts. Okay, 1 second. Okay, so there is many ways, and we can create our own program to manage the containers, and we can do this ourselves. But there is companies that are already in place. The most famous ones are actually Mesosphere, Swarm for sure, for the Docker guys. Okay, and the most famous one is actually Kubernetes. It's getting famous. They have a foundation, which like a standard organization where it's managing the standards. If anybody writes anything to the project of Kubernetes, they will take it and make it public for everyone. So there is many companies today, they are using Kubernetes. It's referred to K8s as Kubernetes. Okay, so it's one of the top projects in GitHub in terms of engagement. Okay, so it's really mature way of handling multiple Docker engines. Okay, and also it has a way to manage other engines, not only even Docker. It can handle, I think, Rocket as well. Okay, it's adopted by Google, in Google Cloud. It's adopted by Red Hat. They make their OpenShift based on Kubernetes. Okay, many of the mentioned here companies, or many of the mentioned here projects are based on Kubernetes. Okay, so it's really a very good way to go forward with the containers. It's actually orchestrating the things. It gives you a very simple mechanism to deploy containers, to maintain it, to scale it, to restart it, it's automatically taking care about everything. It's automatically taking care about scheduling and rescheduling and starting and restarting of the containers that are not starting in the good way or in a healthy manner, okay, everything is really well maintained within Kubernetes. So that was the last part of today's session. It's open now for questions and feedback. Any input?
So right now, Kubernetes and Docker run basically hand by hand. You mentioned that Kubernetes is needed. One of the reasons needed because the container can run in multiple hosts.
Yeah.
So for example, if you have a solution like our solution, so you can pick like 3 hosts to run on, and then it will decide. For us, it's abstract, right? We don't care.
Yeah.
Host it runs. So we tell them we want our containers to run in these 3 hosts, and the combination of Kubernetes and Docker will take care of where to run.
Exactly. Yes, it is. It is that way.
Okay.
So yeah, all you have to do is you just tell Docker in graphical mode or command mode or whatever, I want to scale my environment to a certain level, and then it will be scaled. Okay, that's as simple as that. So for example here, kubectl get nodes, get pods in the main. So we have here identity management. This is identity management service. It's running into, let's say, 2 containers as a term, okay, but we actually use something called the pod. But anyway, we have these 2 instances are running. I can tell Kubernetes, kubectl scale deployment of IDM to replicas. I think replica only 4, let's say, replicas. Okay. It's okay. Dash n core. So I say like this, increase it to 6, increase it to, let's say, 40. Any number, yeah, just fun, right? Okay. You can see here how many containers are started there.
Mm-hmm.
Okay. So just with one single command, I was able to launch with this, for this service, many instances, as you can see. So this is a way that Kubernetes is working. You can simply, now I can push it to switch it back to 2. Switch back to 2. And just with this command, when I run the same again, okay, I can see now everything is terminated, as you can see. Kubernetes is terminating everybody and keeping only 2 running. Okay, so in just without running the command, the Docker kill, Docker whatever, anything, it's just doing everything on the background. I don't need to do anything.
Yeah.
Okay, it's just terminating, and now everything is terminated, and I have 2 instances of that running. Or many things that I will discuss with you in the next session, but it will not be next week because next week we are quite busy. So the week after, I will go step by step. And also I can go back to Docker if we need to touch on some of the capabilities. But I think what we have checked today is enough. Building image, checking logs, okay, environment variables, passing some environment variables is quite okay as introduction or as baseline for us to go for the next step. Because I don't want to spend more time on Docker without touching on the most advanced topics yet. Okay. Omar, are you catching up with this? Are you okay with the topic?
Yes, Mahmoud, yes. Thank you. Yes, it's is describing how it's working. Because from my side, I haven't never worked with this technology, and yes, it's a very nice session. Thank you.
Welcome. Just I want just to ensure that is on the same level of operations. We are not digging deep into development or anything. We just the same level of operator. Like let's say you are interested into operating service manager. Okay, so what you need to know to get the service manager, if they encapsulate it into containers, what will be the things that I need to do. So I want to also to maintain that level. We can go deep. Also, George has a wonderful session. Maybe can George send it to us if you have the link. It's available on the portal for partners about more deep about Docker, and he showed some graphical applications to manage Docker and to manage the the containers in a very nice graphical manner, and to get images and many things in a very nice way. So if somebody wants to dig deep, which is I recommend, we are just touch base on the topics, but I would expect if somebody wanted to know more or to have a solid base, he needs to go more with himself into the links that we have described. Okay, I hope.
Well, just last question. I see you're recording it. Will these slides or recordings be available?
I heard the last recording last week.
Okay.
I had like very bad English, more than any day ever. So I was saying why I would send them this recording. It's really bad, yeah.
No, it's good. It's
really
good.
Bad. Okay, so I was, but now I tried to upload it, but as you can see, the video is removed because it's too long. Then I will post it again, but I will keep the list. I will keep the links for you only. I will not make it public because I didn't like it that much, or didn't like it at all. But just for you as a reminder of what happened in the session. But again, as I said, we are doing this session to have one public session that would be much useful and let's say organized than these ones. So we will make one public soon. Yeah. Okay.
Perfect. Thank you.
Okay. George, I hope I have added something to you today, something new.
No, of course you did, man.
Yeah, well, I'm just trying, to share some of the expertise because I'm really spending so much time with Docker. Last time, I don't know if you have seen, I had like a failed machine. I was trying to fix it for like 10 days of work. So sometimes I know some background things. So I just want to share it with you, and so you don't call me and bother me for fixing things. You can do it yourself.
Much appreciated. So, thank you.
Thank you. You're most welcome. And George, if you have any topic you want to share it, just let me know. Because I'm in go ahead.
I know what I think. I can still do from my side, for example, another session on Docker, similar to the one where we can create, for example, WordPress, to run some databases, to run some Tomcat. But I think for now, and what you have covered, Mahmoud, is enough in terms of touching or understanding Docker, and the guys can take it by themselves if they want to drill more down into Docker. Unless you guys want us to do another session, I can take care of it. But I think now, we should.
I think it will be lovely. I think it will be lovely. Okay, but what I recommend, we go back, we show them Docker, we give them a shock about Docker and how it works, and then when they go back for the session, they will feel it's very lovely. I mean, because we give them a shot of Docker, Kubernetes. Sorry for that. A shot of Kubernetes, and then give them a second session about Docker with you, so it will be quite nice.
Faizan, let's do it. Let's do it this way. We'll do a Kubernetes session, and then we'll go back, and they will find out that Docker is so simple.
So easy. Also, I want to reach the CDF discussion to install CDF, and they know now, like we are in the second week. There another week will be off, then the third week, and then the fourth week we will have the CDF, which is like 1 month to reach the CDF, which is too long. Yeah. So I would think that we will have like a session in the week after, okay, and then we can have like 2 sessions in that week if the guys agree. And actually, I make it 1 session because I am overloaded. Yeah. Okay, so if somebody will support with the session, like you, George, yani, I think it will be great.
I will. So next week will be off, but during next week, maybe Mahmoud, me and you, we can sync up on what. Maybe I'll deliver the session the week after.
Okay. Yeah, or 2 sessions, yani, one session for Kubernetes and 1 session for Docker, for that one. Yeah, and also I got some people interested from Red Hat. I have a colleague that was invited today, called Mahmoud Hatem. He's joining the Red Hat, operating from Cairo. He will be friend of Samah in the future. Okay, so I was inviting him, and he's really interested to hear this kind of session. So, we have some visitors from the outside world.
That's good.
Great.
So
great, guys.
Okay, maybe we invite Ahmed Al-Rais one day. Let's see.
most probably, but knowing Ahmed, he will come and hijack and do his own thing.
Yeah. Which I think we need Kubernetes first, because if he will fill the Red Hat thing, OpenShift, and we cannot go for Kubernetes anymore.
Exactly.
Okay. Yeah. So I think we have a plan for these sessions now. We have a sort of plan. We can proceed. And again, guys, sorry for again, it's not that structured, but really we are all overloaded, so we don't have time to structure it. Then. So please accept my apology for that. Okay, so I will end it now, and I will download the recording and upload the links and send you email with 2 recordings. Okay.
Thank you so much.
And please keep it internally. Don't send it.
Okay.
Keep it within the group. Yeah. Okay. Unless somebody is interested to join the group, we can give him a copy of previous one. Okay.
Okay.
All right. Okay. Thank you, guys. Thank you very much, and have a pleasant.
Thank you, guys. Thank you, Mahmoud.
Thank you.
Okay.
Thank you, Mahmoud. Thanks, George. Bye-bye.
Okay. Bye-bye.
Goodbye.
Bye. Goodbye. Bye-bye.
Salam.